Dan, can you share your screen again? We are live now.
Oh,
and
I'm sorry, what was that?
Dheeraj also.
Hey, Dan.
Hey, good morning. Hey, how's it going? Good evening.
Morning. So I'm in the Washington, D.C. area.
Oh, you are? Oh, fantastic. Oh, great.
So we'll start exactly at 9 p.m. With a keynote from Dheeraj, and then passing the mic to you.
Yep.
And then at the end, we'll have a certificate distribution for the people who have joined, and also any notes that you want to give us. At least we collected initially whatever the sessions were there that you given with me, and that we have already uploaded on our platform. So whenever someone is joining, he gets that link to download that, which has all your course collection for Google on me.
Oh, great. Thank you. Thank you. Yeah, and I'd be happy to share my slides. I was just, I tried to share them on LinkedIn, but I think it was a little too large. I'll see if I can compress those. But if you'd like to send me an email, it would be a good spot to send the slides. I can send those before we get started.
Yes, we can attach it. There's a feature on the platform which we can attach.
Oh, great.
Everything. Yes.
Oh, fantastic. Okay.
Yeah.
Started.
Yes, we can attach it. There's a feature on the platform which we can attach it. Yes.
Oh, fantastic. Okay.
I'm just checking the stream and it's running fine. Yeah.
Oh, great. Super.
Am I audible well?
Okay.
Dan?
Oh, I'm sorry?
Am I audible well? Can you hear me well?
Yes. Yes, I can. Thank you.
And you can see my screen as well, right?
Yes, I can. Here, and I'll start mine as well. Yeah, there we go.
Cool.
That look good? Okay, great.
Are you in California, Dan?
No, I'm actually just north of California in Portland, in Oregon. Yeah.
Okay. Yeah. And it's not that early, though.
Yeah, it's a little bit on the early side, but that's good. It's, it feels like any other day of the week, kind of,
Yeah, that's right.
A lot of us work kind of East Coast hours.
Yeah.
Especially now. Yeah. Yeah, the team that I'm working with now, there are people on the West Coast, there are people in Chicago, and then some folks in Dublin, Ireland. So they're way ahead of us, time-wise.
Yeah.
So we often, get started at like 8 in the morning.
Yeah, a lot of people have moved to their families after. This is the only good thing I see that in COVID, that people are close to family, and that's the good part of it.
Yes. Yep. Yeah. That's true. Yeah. And so, how is it in DC? I heard there was a major storm coming.
Yeah. We already got few of them. I mean, we are not actually habituated for these things. We don't like it. Once or max twice it happens in DC area. So this is the third time in this year it is happening. It's coming tomorrow night and Monday daytime. So I am thinking that school will be closed probably on Tuesday. Monday anyway it is closed for kids.
Mm-hmm. Yep.
Tuesday also I'm anticipating it'll be closed.
Yeah. Yeah.
Yeah, because we are not equipped with all these, heavy storm. I mean, anything happens after 2 inches, everything gets shut. Everything.
Yeah.
They just close everything. It was 3 inches snow on the first storm when it got hit on January 2nd, I guess.
Oh yeah.
And flight were not able to move.
Wow. Yeah.
So we are not at all equipped.
Yeah. Yeah, I used to live in Virginia in Blacksburg, a little bit farther south and west in DC. But yeah, but like 10 years ago, it was a very similar kind of thing. 3 or 4 inches and everything would shut down.
Still it is.
Yeah.
Yeah, but the highways were pretty clean. It was not that bad. Now they're again in airport also within a couple of hours they cleaned up everything, but not like any cold area like New York or New Jersey.
Oh yeah.
So
yeah.
even if a foot worth inch doesn't matter to them, so they clean. They keep on cleaning, and then flight goes on.
Yep. Yeah. Yeah. I think we're gonna have to get used to it. This.
Yeah.
Cool. Yeah. Portland's very similar. It's a couple of inches and nobody knows what to do. People get out there, cross country skis and snowshoes and on the street that way, but otherwise, pretty much it's best not to go driving at times like that.
Great. Yep.
So we'll wait for another 5 minutes and then we'll start.
Okay.
Can you make me a host, because I put a mute and then I want to unmute myself.
You are a host. You and Dan both are a host.
All right, cool. Give me just a sec. I'll be back.
Okay.
So half of the team here is in Gurgaon, Dan, in Delhi.
Oh, great. Oh,
yeah.
And how are
a few of them are in Singapore, and then many of them work from different locations all over India.
Oh, I see. Yeah, very distributed.
Yes. Yeah. So we started 2 years back, and like we have just revolutionized remote work, part-time work, learning in a very different way, making and helping people become T-shaped, and then help them network, communicate, connect, and then upgrade themselves on the fly.
That's great.
Yeah, there are more than 100,000 people who got connected with us, and
wow.
Yeah, in just 2 years, and that's phenomenal. And we're just trying our best to help connect people, technologists at upfront, and change them the way they are working, the way they interview themselves, the way they interact, and the way they build new system. And now with the advent of cloud, how things have changed, right? So it's not like the older story. They need to change, and they need to be very agile in terms of whether they are using Google Cloud or Azure or AWS or Alibaba Cloud, because it's all about the way you use it and the way they charge you.
Yes, it is. But that's fantastic that you've grown so quickly, and that clearly you're addressing a big need there. I think that's fantastic. So I appreciate the chance to join you.
Yeah, and really thank you to you, because it was like I was approaching to for almost a year now, and now I got a chance of half an hour from your calendar.
Oh yeah.
And we do a lot of extensive work on actually data, primarily. Obviously, we extend ourselves to multiple technologies, but data is one of our core areas. So we love to talk with people who are the expert in the data world.
Oh, yep. Oh, great. Yeah, no, it's a great topic, and it's a lot of demand for it now. It's
very hot. Very hot.
Yeah.
So we are just we'll just give 2-3 minutes more for the audience who are a little late.
So that's okay. Yeah, that's all right. It's
so we'll start at 9:02. We'll not keep everyone waiting, because we can see people are joining from all part of the world to hear you.
Fantastic.
That's the beauty of our platform, isn't it, Dan? So we are like so many time zone difference, and
Yeah.
we all are together on one platform. That's the beauty of our platform.
Yeah, no, it's really fantastic.
Yes, we researched a lot on time. And then we thought that this is the only time when most of the part of the people are either awake or going to bed.
Yep.
Yes, either they are having coffee or tea. Obviously, for you guys, it's little early morning. It's a little difficult. I know it's not so specific time supportive, but in the most of the places, at least they can hear. And the WebEx, the beauty of WebEx is if they join early, it has a radio option. They can simply put it like a radio, and then it's everything starts recording up front. So whatever we present today, it becomes a course later. So anyone can join, replay the sessions. Yes, all the sessions are there as course and short sessions, short master classes, and they can replay and see and learn from that.
Oh, that's great. That's great.
And we didn't went to the the basic mode of making things as like there are peer-to-peer conversation where two people are talking, and there are bots hitting your website and then bringing more and more numbers into it. So this whatever is here is just real. Is what people are coming. We just made it real because it's raw. It's for engineers, and we just love to be real.
That's great.
Yes. Yeah, so I think we can start here.
All right, cool. And welcome you all. I welcome you all on Fifth Eye platform for Dan to talk about the data engineering with Google Cloud. Thank you so much, Dan, for giving us a time. We all know that it's a long-waited one. Let me quickly try and introduce ourselves and talk about. I promise I'm not gonna take more than 2 to 3 minutes, and then I'll hand over to Dan, and he can start showing up the whole stuff which he have planned to. Now, going to the next slide, where I would like to introduce the hosting team. We have Mr. Anjani Kumar. You were hearing his voice like a minute back. He's our founder for multi-cloud for you and Fifth IR platform. That's myself, Dheeraj Singh. He is. I'm co-founder with North America division. Gavaskar is our delivery director, and as we speak, we have a whole list of team who are supporting us: Abhishek, Dhruv, Paranjay, Soumya, Rama, Priyanka, Mugdha, and there are a list of different volunteered evangelists with us. We have over 10,000 plus supporters across the globe. Let's move to the. This is what we have. We are almost all over the continent. So North America, we have an office in North America. We have an office in Singapore. We have office in India. We have office in England. So kind of we're covering almost all of the places. So Fifth IR is nothing but Fifth Industrial Revolution. Let's talk about. This is one of the very interesting. Thank you so much, by the way, Dhruv and Gavaskar, for putting this together. We were thinking of collecting all of the data to see that what exactly who all have registered with us, who were the mentor with us. So surprisingly, we have, and we realized recently that we have touched almost all of the industries. Experts
and
in
to
IT
add up,
field.
here, this is just for that session. We just collected data.
Exactly.
You see the diversity, Dan.
Exactly. So you name a IT growing and grown up companies, we have arranged, or we have we've touched them. So this is one of the phenomenal thing which we just recently came across, and this we built by
all
the
your
way.
fans, so these are all people who are fan of you and your teaching and your training. So you can see that.
No, thank you.
Thank you.
This is part of RBI, Dan.
Thank you.
And so this community benefit, I just want to quickly talk about this through Fifth IR. So it's like part of, we can claim the certificates, and we arranges the exams. We help upgrade different group of experts, or different group of people who are looking at to grow themselves in a short session, longer session, so voluntarily, people who are already into the industry for years of experience, basically they are creating sessions, giving sessions. Like we all know Dan, who he is, and he's in our platform like that. We have a lot of people helping here to the community. We arrange the evangelist certificates. We provide training partnership with cloud and companies. We arrange all these things for job seekers and learners for education. We have a paid program. We have a volunteer program. You can always go in fifthire.com and you can search about those different sessions, free and paid both. This is for all of the people who have connected through YouTube, and so there will be a question answer session at the end, but you can always feel free to put your question on chat, and we will try and address as quick as is possible. But what we normally do, we try and keep at the end around 5 to 10 minutes of a session where we talk about all of the questions. We try and address all of the questions. Of course, these are different sessions which we are planning and we have. This is really interesting. So I'm sure a lot of data people would be knowing at least few of the people in here. So if I can take over my mouse and show him, he's a Bill Imon, who's a father of data warehouse. He had come to our platform and talked about the whole data processing. We have Dan, of course, we all know him. We had Jeff Warr, who is the chief evangelist in Amazon. So like that, we have really big people, vice president, directors, senior directors of different companies, different leading companies we have. We've already had pleasure to have them on our platform. Let me quickly introduce you to Dan. He is principal engineer and instructor and author. So you can reach out to him through the LinkedIn. You can always reach out to him. He's available. He's prompt on LinkedIn. Now, this is what the multi-cloud for you certificates will look like. You can claim your certificate after the session gets over, and we will talk about it, how you can claim your certificates. I think it's very simple and straightforward. You can just go on fifthir.com and we'll talk about it once the session will go off. All right, and here is Dan. Dan, over to you.
Great, thank you. And I just want to say how much I appreciate the chance to be here, and I love talking about Google Cloud and data engineering, data science. So it's great to have this opportunity here. And I'll just get my screen oriented here. There we go. So today we're going to be talking about data engineering, and this is going to be something of a little bit of a whirlwind tour because there's a lot of topics in data engineering that we can talk about. And so what I'm going to focus on is primarily kind of the main parts of data engineering, which really focus on things like storage and processing and analysis, machine learning. So, with that as kind of the backbone or the framework to work from, I want to look at specific Google services that we use when we're doing data engineering. And so, I think, thank you for the introduction before. I'll just skip over. So I do a lot of work with cloud, Google in particular, a lot of AWS as well. But definitely Google is sort of my preferred cloud platform. Now, as I had mentioned, one of the things that we need to work with right away with data engineering is storage. And in GCP, we have a few different options with the types of storage that we work with. First of all, there's object storage, and the service for that is called cloud storage. We also have storage for instances. So if you're running VMs or if you have a Kubernetes cluster, we'd have access to persistent disks. And then when Google talks about storage, they kind of lump in the databases as well. So we have both, SQL and NoSQL databases, plus we have the analytical database, which of course is BigQuery, and I will talk about that a little bit more. But first I want to focus on cloud storage because that's often where we get started. This is where we kind of store the bulk of our data. It tends to be anytime we have unstructured data, that typically goes to cloud storage. So if we have images, videos, text, anything like that, but also just large files, archive data, data that we might want to use for training and machine learning. It's also used as temporary storage between services. So that's really important for us in data engineering because we often use pipelines. And so one service will produce some output, and then we need to stage it for another service. So that's where cloud storage is also quite useful. There we go. And of course, another nice thing about cloud storage is it's basically globally accessible. So pretty much anywhere you're working, you can have access to cloud storage. Now, because it's globally accessible, it also uses a global namespace. So our buckets, we have to name them with unique names, just as if you were doing a URL for a website. But within the cloud storage system, you have access to buckets, folders. Folders are organizational units within buckets, and then we have objects. And those are the things, for example, files that we upload that we treat as objects. Now, the storage classes, there's several different kinds of subtypes of cloud storage classes. There's high performance storage, otherwise often called like standard storage, that we typically use for like frequent access to files. So again, if we were using staging areas in between pipeline components, we would use high performance standard storage. A lot of data, say for machine learning training or your archiving data, there's a few different kinds of backup and archival storage. And really the difference between them is there's lower cost as you go down. So nearline is less than standard storage and archive costs the least, but you are charged for accessing. So typically you use nearline only if you're going to access files, typically less than once a month, archive like less than once per year. Now, one of the nice things about cloud storage is that it manages redundancy. So in terms of high availability, you can have regional storage. So data is stored in a single region, but replicated across zones. So of course, like other clouds, Google has regions, and within these are fairly large geographical areas of the region. And then within the region, there are multiple zones, which are, you can think of as like data centers or clusters of data centers. Now, cloud storage also supports dual region, so you can store in store in two regions and auto failover if needed, and there's also multi-region. So depending on the level of availability that you need, you can kind of choose your storage category accordingly. Now, one of the nice things about cloud storage is it has an automated object lifecycle management system built into it, which allows you to do things like automatically move or migrate data from, say, the higher cost storage, like the high performance storage, into the lower cost storages like nearline, cold line, and archive. And that's really useful if you want to keep data around, but you're typically not going to use it. And this is often the case with machine learning, where we're getting to the point where we typically want to save as much data as possible. Basically, any kind of data we have, we want to keep it because we may need it in the future, and we can't anticipate all the use cases. So that's really a good use case for archival storage. And with object lifecycle management, we can push the data through different tiers of storage so that it can help us control costs. We can also define retention policies. So for example, if by some kind of industry or government regulation, you're required to retain data for a certain period of time, you can define retention policies so nobody can accidentally delete something. And then we can also define object holds. Again, say if you have a bucket that has logs and you don't want anybody tampering with the logs, you can put an object hold on objects so that they can't be deleted. Now, with regards to security and cloud storage, a couple of things to keep in mind. Basically, anytime data is at rest in Google Cloud, it's encrypted. Doesn't matter what the platform is or what the service is. Now, by default, Google will manage the encryption, but customers can also manage their own. They can manage their own keys using Cloud Key Management Service, or bring their own keys and manage them in there as well. And of course, with Google Cloud and cloud storage, Google maintains activity logs, so you can basically keep track of who has been accessing the data in cloud storage. One of the real problems with data engineering, of course, is loading data. Now, depending on the volume of data you have different amounts, or excuse me, different ways of loading data. So if we're dealing with relatively small amounts of data, you can simply use the console or the command line and upload the data into a cloud storage bucket. If you're dealing with very large amounts of data, there are two services you can use, the cloud storage transfer service and the transfer appliance. Now, if you have a small amount of data, you can use, for example, a console. Here's just a screenshot of something very simple, uploading a file into a bucket. Now, the cloud storage transfer service is really useful when you're working with data, like large volumes of data on premises or in another cloud. And what it allows you to do is transfer data. So, and you can also use it between storage buckets within Google Cloud, but it allows you to basically schedule a transfer, and those transfer jobs can be executed on a recurring basis if you'd like. So, for example, if you need to migrate a lot of data from AWS S3 storage, cloud storage transfer is a good option for that. A general rule of thumb is if you're transferring data, say from on-premise, and you have less than a terabyte, then you can use GSUtil, the command line utility. But if it's greater than a terabyte, it's probably better to be using the cloud storage transfer service. It's just more reliable. Now, transfer appliance is a high-capacity physical device which you can basically order, which you can order from Google, and it'll be shipped to your data center. And from there, you physically attach the appliance to your network, copy the data over, and then send the device back to Google. And once Google receives it, they will upload the data into your buckets in cloud storage. So that's typically done when you're at large capacities like 100 terabytes or more. And the appliance comes in two sizes, currently 100 terabytes and 480 terabytes. Now, also with regards to security, there are a couple ways to do access control. There is the preferred method, which is known as uniform bucket level access. And that uses IAM, or the Cloud Identity and Access Management Services. And basically it allows us to find identities and roles that have certain permissions, and then granting those roles to different identities. And it's a very centralized way of organizing access controls, and it's very fine-grained, so you can really tune your roles to fit your particular needs. Now, another option is called fine-grained access control, and that's considered a legacy method, kind of like the basic or primitive roles in IAM. They use access control lists, and again, this can be used, but in general, the preference is to use uniform bucket level access. Now, so that wraps it up for cloud storage. So that was the object storage. That's kind of the bulk, sort of coarse-grained storage system. Now, a lot of times we also have to work with data at a much finer grain detail, and relational databases are a good option for that in many cases. So in particular, if you have structured data and a predefined schema that's relatively stable, then relational databases are good options. And the relational databases provide a lot of different kinds of abstractions around the data that are quite useful when doing a lot of manipulation on the data or a lot of querying on the data. And these include organizing the data into tables, using indexes for performance considerations, allowing us to create views, which are different ways of looking at tables or combinations of tables, and then other features like partitions to improve query performance. Now, relational databases, by their very nature, they support ACID transactions, so it's atomic, consistent. So that's very important that from a database perspective, ACID transactions are often really important, especially in online transaction processing systems. And they often offer strong consistency. And here the idea is anybody reading, say, a piece of data from anywhere in the globe will get the same answer depending on what the state of the database is. You're not going to get two different answers at the same time, which can happen sometimes in databases which are eventually consistent, but relational databases support strong consistency. All right, that's there. Now, when it comes to defining the database, we work with SQL or SQL, which is the structured query language. And the SQL can be divided into a couple of different subtypes. There's the data definition language, which we use when we're creating our schemas and defining our indexes and other structures. We can create tables for storing the data and indexes for improving access time at a fine-grained level, like specifically what data block to go fetch when I want a particular row. We can also use partitions, which is sort of a coarse-grained chunking of data so that we can eliminate or more quickly identify particular pieces of data that we're interested in. Now, when we're querying data, we use data manipulation language, and that's basically the select statement. And it's very, as the name implies, it's very structured. So if you're interested in data engineering and you haven't learned SQL yet, I would say that's definitely one of the first things to learn. Pretty much anywhere you go in data engineering, SQL will be useful. Now, when do we use relational databases? Again, when we have structured data. When we're doing transaction processing applications, so anything like an online e-commerce site would be transaction processing. When we need strong consistency, we often turn to relational databases. And that in the past, relational databases have really been the only databases that provided strong consistency, but now some NoSQL databases can be tuned to stronger or less eventual consistency. Support for ACID transactions, of course. And oftentimes we need to support the SQL query language because a lot of the analysts who might be working with the data are familiar with SQL. Now, there are times you don't want to use relational databases. So for example, when you're doing data warehousing in Google Cloud, you really want to turn to an analytical database like BigQuery. So I would say very large data warehouses. If you're doing small data warehouses, then something like Postgres will work well. But if you're getting into multiple terabytes and petabyte scales, then you really want to be working with an analytical database like BigQuery. When you're working with unstructured data like text and video, you want to be working more with object storage typically. If you're working with semi-structured data like JSON structures and it's hierarchical, then document databases work really well. There are also wide column databases, which are especially useful when you have low latency writes. For example, if you're reading IoT or ingesting IoT data, the Bigtable is a very good option there. Now, in Google Cloud, there are two options for SQL. For relational databases. There is Cloud SQL, which is a sort of a regional-based database service. And you can have regional data stores. You can use multiple zones for high availability. And you can also have multiple regions, but it's basically for backup only. It's not, you don't have like a multi-region support. And you can have up to 30 terabytes per database. So it's fairly limited both geographically and size-wise. And when you use Cloud SQL, you have the option of using either Postgres, MySQL, or SQL Server as the underlying databases. Now, if you need something more in terms of, say, global support or multi-region support, then Cloud Spanner is a better option. So Cloud Spanner is a globally distributed database. It provides high availability, and it uses nodes, so it's horizontally scalable, and it can store up to 2 terabytes per node, so you can have very large databases. And also because it's a managed service, you don't have to worry about things like setting up your own replication or managing for downtime. So that kind of wraps up the relational side of the world. Let's take a look at NoSQL databases. So there's two that we typically work with in Google Cloud. There's Firestore and Bigtable. Now, Cloud Firestore is a managed service, and it is, as I mentioned, a NoSQL databases, and it uses the document model. And basically what we have here are basically hierarchical organizations of key value pair structures. So if you're familiar with JSON structures and hierarchical JSON structures, that's the kind of data structure we typically work with in Cloud Firestore. And there are two modes, native mode and data store mode. Data store is sort of an older version or the precursor of Firestore. That was the earlier document data store. Now, we typically use document databases when we have semi-structured data and the schema is not fixed, it changes over time. So for example, if you're working in an application where you're keeping a lot of attributes and the attributes might vary. So for example, in a catalog, say you had a competitor to Amazon and you have a large number of different kinds of products that you're selling. Each of those products can have different kinds of descriptions or characteristics that you want to keep track of. In that case, something like a semi-structured data structure, like a JSON structure, is a good option for modeling that. Typically, we use document databases when we want to query on multiple attributes. And another thing to keep in mind with Firestore is bounded ingestion volume, and that basically means we're not going to overwhelm it. We don't have to do a lot of high volume, low latency writes. If that's the case, then you probably want to look at Bigtable, which is another NoSQL database that is managed by Google. And Bigtable is what's known as a wide column database. And if we think about it, relational databases, they're built on the abstraction of a table. Or if you're familiar with a spreadsheet, you know, a tabular structure is sort of the core foundation for relational. For document databases, it's hierarchical key value pairs like the JSON structure. Wide column databases are different. They are based on a sparse multidimensional matrix. So it's highly efficient for dealing with high dimensional data that's highly sparse also. So there are a number of use cases. Typically, if you're at any kind of petabyte scale, if you're doing analytics, you're probably using BigQuery. But if you're doing a lot of data ingestion and lookup of specific, particular values, then Bigtable is a good option. It provides low latency writes. And key-based reads, here the idea is that there is a single key that we use to look up a value. BigQuery is also good at range scanning, but you don't do things like joins or do have like a where clause in Bigtable the way you would say in a relational table. So Bigtable is useful if you're running a lot of analytics, or if you have any kind of time series data like IoT or like finance data. It's very useful for that. Now, just to give you some sense of other kinds of wide column tables, HBase, which is built on the Hadoop platform, and Cassandra. Cassandra is probably the other popular choice if you need a wide column database. But the advantage of Bigtable is that it's a managed service. And so when you're using Bigtable, you can specify cluster configuration, like the number of nodes that you want to use, what kind of persistent disk do you want to use, and where you want it located. And Bigtable scales linearly, and it provides high availability if you use multi-region clustering. Another nice thing about the HBase API, about Bigtable, is that it provides an HBase API. So if you're working with a Hadoop cluster on premises and you want to migrate to Google Cloud and you don't want to manage a Hadoop cluster anymore, but you have applications that make use of the HBase API, you can migrate that data to Bigtable and still use your HBase API-based applications. Now, Bigtable is also distributed, so it has multiple nodes, and each node itself manages a set of SS tables or sorted string tables. And one thing to keep in mind about Bigtable, when you set up the clusters, what you store on the nodes is actually metadata about the data that's stored in Colossus. And Colossus is the global distributed file system that Google developed. And so the data actually isn't stored on your nodes, it's stored in Colossus, but the metadata about that node is, metadata about that data is actually stored on the nodes in the Bigtable cluster. Now, an important thing to keep in mind about Bigtable is this idea of a row key. And it's somewhat analogous to a primary key, but it uniquely identifies a row in Bigtable. And it's similar to primary key in the sense that it gives you a unique identifier, but it doesn't support joins, so there's really no concept of foreign keys. And the row keys determine where the data is written, which node is going to be managing that data. So how we structure our row key is really important. Because one of the things we want to avoid in Bigtable is known as hotspotting, which is when we have a lot of, say, write operations or read operations on a single node. And so if the workload isn't distributed across all of the nodes, you're not going to get the kind of performance that you really can. And that's a problem not just with Bigtable. The same kind of problem can occur, for example, in Cloud Spanner, if you organize your data in such a way that a lot of the work is targeted at just a single node or a small number of nodes. Now, another way of dealing with large volumes of data, or another service for that, is BigQuery. And BigQuery is a serverless data warehouse, so you don't have to manage servers for BigQuery. It also supports petabyte scale data warehousing. And now, it uses SQL as a query language, but it's not really a relational database when we think about things like Postgres or MySQL or Oracle or SQL Server. It's really different. It's much more like a Redshift or a Snowflake in that it is the compute and the storage is decoupled, and we use different kinds of storage methods. Typically, it's a columnar storage, which is really useful for analytic operations where we're reading large volumes of data, but maybe just a small number of attributes. So it is, under the covers, it's quite different from relational databases. And these are typically called, as I had mentioned, analytical databases. Now, in BigQuery, we have the concept of data sets. And data sets are collections of tables and views. And tables in BigQuery are interesting. They support, of course, scalar data types like integers and floats and strings. But you can also have nested structures like arrays or record structures. And Google announced support for JSON within BigQuery. So that's really a big advance. If you're familiar with Postgres, you may have used the JSON-B data type. It's really helpful to be able to have relational structures, but then for some attributes that might change quite a bit, where you need a semi-structured organization is more useful. It really helps to be able to use JSON. So now we have that option in BigQuery as well. And the data sets in the tables in BigQuery support partitioning, so we can sort of logically chunk up the data. And it also supports clustering, so data can be kind of kept in a sort order, and that is helps a lot with performance, particularly when we're reading data. Now, views are projections of excuse me, I'll get on. Views are projections of one or more tables. So that basically means we can take subsets of tables or combine tables using joins, and then create particular views on a particular set of tables there. Now, views can be materialized. So this is really important if you have a complex join that may take a while to run, and you want to use that the results of that frequently, then we can materialize them or save out a persistent copy of that. And that can that's one of the ways we can improve performance. So when you're working with BigQuery, you can work in a query editor. So it's if you're familiar with like pgadmin or other tools like DB Visualizer, it's kind of a similar kind of environment to that. And you have access to the data structures, so you can navigate around tables. And one of the things that's really important when you're designing a BigQuery database or data warehouse is to think about partitioning. And with partitioning, we can divide tables into segments, and these segments are called partitions. And they're really helpful in improving performance because it allows us to focus our scanning on just a small subset of the data. Now, BigQuery uses SQL, but again, I'll emphasize it's not a relational database. So for example, we don't define indexes in BigQuery. The way we get data back, or we go look up data in BigQuery, is we do scans across chunks of data. And so when we are scanning, one of the things we want to do is try to isolate the amount of data that we have to scan or reduce the amount of data we have to scan. One of the reasons is because we are charged based on the amount of data that we scan. So partitioning is really useful, one, in query performance, and also two, keeping costs down. So there are no indexes, so it doesn't even generate them automatically. BigQuery just scans, and it's a design choice that is often used in highly distributed databases. It turns out, from a practical matter, it's actually more performant to do scans rather than to build and maintain indexes and then use indexes for lookups. So now there are different ways we can partition. We can partition by ingestion time. So this is really useful if you have like IoT data. We can automatically create new partitions if we use ingestions by time. So each day, for example, a new partition is automatically created. And the time that the data arrives is the thing that determines what partition it goes into. And when that happens, BigQuery creates a pseudo column for partition time, which you can use in your queries. Now, you can also control the date or timestamp that is used. So instead of using the ingestion time, if you have some other timestamp column, say like an event time, if it's an IoT or like a monitoring service, you might have an event time, and that occurs at some point in time, and then the data is then later delivered to BigQuery. Well, we could use that time to partition the data. So this is a couple things. Because it's a piece of data that you've already defined in your model, there's no need for a pseudo column. But there are a couple of special partitions that are used to handle sort of unexpected cases like a null value, or if there's something outside the partition ranges that you've defined. There's also integer range partitioning, which uses, of course, an integer value, and you can specify an integer range for that. Now, clustered tables are a way of organizing data within the table so that the data is sorted based on values in one or more columns. And this can definitely improve performance on things like aggregate queries, where you want to, say, focus in on a particular set. If things are within a sort order and you want to get a particular range, again, this can help with the performance. And it also, because it allows you to focus quickly, we have the option of scanning less data, which again can save us on the overall cost of the BigQuery. So that's kind of the end of the storage piece of this discussion. So we've covered things like object storage, relational databases, NoSQL databases, analytical databases. Now, how we get the data into the database is really another major part of data engineering. And so I want to talk about a couple of services that are really important for processing the data and basically preparing it for analysis. One of them is Cloud Dataflow. Now, Cloud Dataflow is a service that's used for stream and batch processing, and it implements an Apache Beam runner. Now, Apache Beam is an open source model for batch and stream processing. And there are other Apache Beam runners, like Apache Flink is an open source tool which you can use. So if, for example, you're in Google Cloud, you're using Dataflow, and for some reason you want to move a job, say, to AWS or Azure or on-premise, you could run, for example, Flink in any of those environments and use your Dataflow application. Excuse me. Dataflow is horizontally scalable. It's a managed service, so there's very little sort of implementation details that you have to deal with. And it also supports windowing operations, and that's really important for stream processing. So, for example, you might have an IoT system, and you're ingesting data, and sometimes the data is delayed. You can define, say, periods of time that you want to aggregate data, say every minute or every 5 minutes. Those are windowing operations allow you to do that. And then you also have the ability to implement things called watermarks, which might say, okay, if all of the data, say, after a certain time or before a certain time has not arrived yet, we'll assume it won't arrive at all. So a watermark gives you a way of saying, okay, don't expect any more data. We can apply the aggregate operation on the window and assume that that window is closed. And these kind of features like windowing operations and having watermarks are really important for stream processing operations because they help you implement fairly what could be complex logic relatively simply. So definitely, if you're interested in working with stream processing, then definitely Cloud Dataflow is a service to take a look at. Now, Dataflow works with the idea or the concept of a job, and you create different jobs and run them, and those are basically your processes. And with Cloud Dataflow, one of the nice things about it is it comes with a bunch of predefined templates which you can use. And these templates can be based on things like where data is coming from and where it's going. So for example, you might read from Cloud PubSub and write to BigQuery. There's a template for that. And there are templates for just many combinations of things, like if you're working with text files or Avro files, if you're writing to BigQuery or to Bigtable, there are different templates that you can use as starting points for building your jobs. And here's an example. It's very visually driven if you're using the console about how you create a job from a template. And also, you can basically monitor the execution of your job in the console. Now, in addition, there are other things you can look at besides, just the high-level details. You can look at, sets of jobs that are currently running, what's the state of various jobs, as well as information on the kind of resources that you're using. And here's just an example of some job lists here. I had one where one failed, but others are running. Now, the other sort of data preparation service or data processing service that's commonly used is Cloud Dataproc. Now, Cloud Dataproc is a managed Spark and Hadoop service. So if you're running a Hadoop on-premise, or you're using Spark on-premise and managing a persistent cluster, then Cloud Dataproc is a really good option if you want to migrate to something that is a managed service. And Cloud Dataproc is used for large-scale batch processing, typically, and machine learning. There is support for stream processing in Spark. That can be used, especially if you're already doing stream processing in Spark and you just want to move it to the cloud. That makes sense. Cloud Dataflow is probably a better option for most stream processing high-volume applications. But again, if you've already have something written in Spark stream processing, then you can certainly run that in Google Cloud as well. And Dataproc is often used for ETL and ELT processing. One of the nice things about Cloud Dataproc is that you can spin up clusters fairly quickly, like in a minute and a half, you can have a cluster spun up. So what that means is you don't have to do what we used to have to do, which is basically set up a cluster and leave it running, because it would take so long to start up a cluster, and when you shut down a cluster, you'd have to copy data off the cluster into object storage, and the next time you start a cluster, you have to copy the data back. So there was a time where it was just easier to leave the cluster up and running. That's no longer the case, and so that's really helpful from a cost perspective. And again, you can set up the cluster in a console, and it's if this feels familiar, if you're familiar with like Compute Engine, this should look very similar, because what we're doing is basically defining nodes and creating managed instance groups. So we're going to be, when you define a cluster, you can pick machine types and specify configurations of the machine type. Now, Spark also has this idea of a job, or this concept of a job, which is how we run applications. And so you can create also from templates as well. Now, one of the really helpful things about Cloud Dataproc is it uses or makes available a cloud storage connector. Now, that's an open source Java library, and it allows Cloud Dataproc to use cloud storage instead of HDFS, which is the native Hadoop file system. And the reason this is helpful is because now you have basically decoupled the processing that Spark does from the storage system. So the nodes can be added or released, and we don't have to worry about, say, copying data off those nodes, off the persistent storage attached to those nodes, to something like cloud storage. Instead, cloud storage looks like essentially like a virtual HDFS system. And this is really useful. First of all, it's automatically installed, but there are some other benefits too. We have direct access to cloud storage. We still have HDFS compatibility. And it makes our data more accessible. Across multiple clusters, for example, it's more easily shared. And of course, we have high availability. And it really reduces the storage management overhead if you don't have to worry about HDFS and think about how much attached storage you have on a node. So those are sort of the two core processing services, Cloud Dataproc and Cloud Dataflow. Now I just want to take a look and talk a little bit about Cloud Composer. Now, Cloud Composer is a managed Apache Airflow service. So here again, we have a widely adopted open source project, in this case Airflow, which is made available to us as a managed service. So we don't have to install it, set it up, and sort of keep it patched and running when we use the managed service. And basically, Composer is a service for executing workflows. And we define these workflows as directed acyclic graphs. And we can manage these through the console or command line, just like pretty much anything else in Google Cloud. Now, a workflow is a collection of tasks, and those could be anything from copying files to deleting files, loading data into a particular storage system. And the DAGs themselves, or the directed acyclic graphs, these are programs that are stored in cloud storage. And they also support a number of different plugins and hooks. So based on certain events, you can trigger workflows and do certain operations. And we do this all in Python. So for example, if you looked at a directed acyclic graph, you're actually looking at a Python program. So that's really useful because a lot of times in data engineering, we are typically working with Python. Python is kind of like the language that is most widely used, both across tools for data loading and for analysis. Now, another service that we have available to us is Cloud Data Fusion. And Cloud Data Fusion is a managed service. Now, again, it's an open source, or based on an open source project. This one is CDAP, and it's an analytics platform. And it basically provides like a code-free or a GUI-based ETL, ELT development platform. And it has a lot of different connectors and transformations. So it's basically like a drag and drop kind of tool. And in terms of running Cloud Data Fusion, it's deployed as an instance. And Google provides 3 different levels of kinds of features that are available. The lowest level, sort of the most basic, is the developer, which is very limited. It's good, it's kind of like if you want something like a development environment that costs as little as possible, then developer is a good option. There's also a basic version, which has like a visual designer and SDK. And then at the enterprise level, you have things that you typically need when you're using something like Data Fusion in a production environment. So you can, for example, support streaming pipelines. You can have things like schedulers and trigger based on events. So that's Cloud Data Fusion. And here's just an example of what you might expect to see. If you're familiar with other ETL tools or graphics-based ETL tools, it'll look very familiar, where you have palettes and workspaces, and you basically kind of build your ETL process by, connecting operations. So that is sort of one side of data engineering. It's sort of the analysis, storage, controlling workflow. And now another part of data engineering it's tightly coupled, but also at the same time we're tending off into a whole different discipline, is machine learning. So I want to cover a little bit of machine learning and how it fits in with data engineering, because it's really kind of one of the most important use cases for data engineering. There's the analysis that we typically do, kind of like a BI analysis. That's very important. But now machine learning is increasingly important as well as a use case. Now, there are a few different kinds of machine learning. There's unsupervised learning, supervised learning, and reinforcement learning. And unsupervised learning, with unsupervised learning, we draw inferences from data. Now, and what we're looking for is previously undetected patterns. And some examples of these are like clustering. If you have a set of data and you just kind of want to understand it at a high level, like what are the natural groupings that might emerge from a data set, we can use clustering. Anomaly detection is another case where we can look at patterns over and over again, for example, in time series data. And there may be cyclical patterns or seasonal patterns that we can detect. And if that's the case, then we can also detect outliers or anomalies that fall out of that predicted area. And then there's also principal component analysis, which is a kind of dimension reduction technique. So if you have a large number of features and you want to try and understand what are the most important features, we can use principal component analysis for that. With regards to supervised learning, there's some learning from examples. And here the basic idea is that we want to be able to predict a category or a value. And so there are things like having an image. Say you're looking at a medical image of tumors and you're trying to do cancer diagnostic and you want to know if a particular tumor is malignant or not. Or if you're a service that's designed around selling houses and you want to predict what's the price a house will sell for. Or in the case of financial services, you want to be able to quickly identify fraud. All of these are examples of supervised learning. Now, there's a third category called reinforcement learning. And in reinforcement learning, we're basically learning from the environment. And the idea here is, or the objective is to maximize some kind of reward or feedback mechanism. Now, we don't require like labeled examples. And so it's a combination of exploration and just probing like the environment. It's a kind of learning that occurs when you have an agent taking actions in an environment and then getting feedback from the environment. Now, reinforcement learning isn't as commonly used as unsupervised and supervised learning. But here, let's just take a quick look at an example of supervised learning. These are irises, and a classic example in classification is can you classify irises based on certain features like the petal length and the sepal length and width. And what you'll notice is those are our 4 attributes, for example, that we can look at. And then we have labels, which is an attribute that is predicted, and it's a category of an entity. And basically what we're trying to do is use algorithms to build models that predict the labels. So we have 2 types of attributes that we work with. There are the features, which are the things that are, essentially it's the input. These are the parameters we use in a model to try and guess or estimate a particular label. And that label could be things like what kind of flower it is, whether or not something is a fraudulent transaction or not. Now, sometimes the set of features that we start with, a set of attributes, is sufficient, but it may not be all the kinds of features that we need. So some of the features may need transforming. So we need to, say, change the structure of a feature or break things up a little bit. Or we might need to derive other features. So, for example, we might need to combine 2 or more features into what's known as a feature cross. And this, when we do that, what we're trying to do is make explicit certain characteristics of an instance or a training example, make them more explicit so it's easier for the algorithm to basically pick up on it. And we use feature engineering to improve the predictive capability of machine learning models. Now, the process that we go through with machine learning is basically we start with training data, and then we build a machine learning model. And so this is basically a model that will make the predictions. But then we have to check it. Like basically we use validation data, which is like training data. It's a similar kind of structure, but here what we're trying to do is we're trying to understand how well is our model working, and do we need to tweak things. So for example, depending on the kind of model you're using, there are different characteristics of that model that we can change. And so, for example, in a deep learning model, we have the number of layers that we have in the model. Or if you're working with, say, random forest, you can have a maximum depth of tree that you can specify. Those kind of characteristics are known as hyperparameters, because those are things that we specify for the model. It's not something we learn by looking at the training data. So the validation data helps us understand how well our model is performing, and we can adjust our hyperparameters based on the performance that we're seeing with the validation data. And that's that tuning process. And then so we can change these hyperparameters, and then we continue to train the model. And then eventually, when we're satisfied, like we're not getting any improvement based on our tweaking of the hyperparameters, then we can use test data to actually measure the quality of the model and how well it's working. And that's where we get into evaluation. And here's where we want to know, how well does the model perform? And there are different ways of measuring performance. Accuracy, precision, and recall are often used, like with classification. And with regression models, where we say predicting like a house value, we often look at like mean squared error. So how far off on average are we? So those are the ways that we can look and evaluate machine learning models. Now, I just want to open up in QA. This, again, I sort of covered a lot. There were a lot of things that I haven't covered. Someone raised a question about Cloud PubSub. That's a really good point. Yeah, Cloud PubSub is really important for ingestion, and it's a messaging service. And yeah, definitely Cloud PubSub is important on data engineering, and just, time-wise, maybe we can do another session where we focus more, just even on ingestion. We could probably spend an hour just talking about that. But then there are other services as well that you're probably going to be using, certain things like metadata catalogs and things like that. We haven't talked about that as well either. But at this point, I will open it up to Q&A, and also just mention a few other sources. Did some Udemy courses. There's a discount code there. The study guide, which is a book. Also a couple of free options. Free Code Camp's a great service, which has some other training materials. You can get courses there. And also, there's a great GitHub resource on how to become a data engineer. I'd recommend that. And so with that, I'll leave this open. And let's see, I will see if I can access the questions.
Yes. So we'll add this up all in the document that is there. So we'll create obviously your slide would be there, and in the slide, if you can add this up, obviously this will be the part of the slide, right? When you share.
Yes. Yep. Yeah. So everyone will have access to that. Yeah.
Yes.
So I'll stop sharing here. So if we get to.
So this will be slides will be available by tomorrow at the max. And they will have, it will also have the high quality recording, which we are parallelly recording. But instantly, if anyone go and see there, currently the live stream which are there, it's already there and is being played. So even who didn't join or who had some issue joining, they can come anytime in the future, and it will be looking like as Dan is speaking right at that point of time. So.
Okay. Right.
I would like to request something to all of the audience people. We desperately need your feedback, because this is something we can keep on improving on stuff, and we can make sure that we're bringing in much more interesting and better sessions to you guys, all like the way we did it. So we need your help, all of the guys who are listening here in the WebEx side or YouTube side. If you could provide us the feedback, that would be a great help to improve ourselves in any way. I mean, whatever way you think is improving requirement.
Coming back to questions. So first question looks like so the people are talking. Then at the one point, people on YouTube are happy to put their questions there. We'll pass it to Dan. definitely, or on our platform, they can send it through Facebook Messenger, which is live on the platform, or through Telegram, whatever they prefer. But we are coming up with the questions here. So the first question.
I see a couple of questions in chat I can address while you're working, the other questions are coming in.
Yes.
So let's see. So there was a question about did the index get generated automatically? I believe that was when we were talking about BigQuery. And yeah, no, again, I think I had mentioned BigQuery doesn't use indexes at all. So it just uses scanning. So it really is different in that way from relational databases. Someone asked how cluster table is different from partitioning. Partitioning is also known as sharding, and that's basically breaking up the data in a table into logical chunks. So for example, you might partition all the data for one that comes in one day is in one partition. Now within a partition, you can have the data either in the order that the data arrives, or you can keep it in some kind of sorted order. And when it's sorted, maintained in a sort order, that's called clustering. It's a little bit of an unusual term. I'm not sure what they call, I guess because things that are similar to each other are clustered close to each other when it's in sort order. But really, you can have both partitioning and clustering. There used to be a time where you could only use clustering with partition tables, but now even unpartitioned tables can be clustered. If they're small enough, it'll be performant enough. And let's see. This is similar with SSIS and SQL Server. Oh yes, there was a question. Is this similar to SSIS and SQL Server? I'm not that familiar with. I haven't used SQL Server in quite a while, but I believe that yes, like Cloud Data Fusion is similar to SSIS. It's an ETL tool, very graphical. But if anybody who's familiar with Microsoft SQL Server, if you know more specifically about SSIS and how that kind of fits with like Cloud Data Fusion, yeah, if you could kind of post something in the chat, that would be great. I think I'm just kind of scanning for other questions in the chat, and I understand that there's a limit. PySpark.
There is one question on
PySpark,
YouTube. There's one
Will
question.
that help?
People are one of the.
Oh, sure.
One of the joinees asking that what is the best way to learn machine learning for the beginners?
For beginners, I would say there's a couple things, a couple of resources. Andrew Ng from Stanford, Google. He was a professor at Stanford. He's been at Baidu, Google. He started a new source. He has a machine learning course. If you just Google Andrew Ng, his last name is spelled Ng. He's got a great course.
If you can type in the name there, I'll pass it to on the YouTube.
Great. Yeah. And then, gosh, I'm blanking on the name. There is a great website that's dedicated to machine learning, and I'm blanking on the name of it, and I will come up with it. But basically, it's someone who explains machine learning in a series of blog posts, and it's really designed for people who want to understand machine learning, but not deal with like all the deep level math and things like that. So I will look that up, and yeah, I will pass that on as well. Those would be, of course, sessions like this, but definitely if you want to kind of learn on your own and have something structured, that's where I would go for, I would start with Andrew Ng's course first. Let's see, here's a question about the GCP Professional Data Engineer Certification Exam. Are there any changes in 2022 we need to prepare for? That's a great question. I don't know. I mean, I've worked with Google on like the official study guides, but I don't have access to the tests. I don't help make up the tests. I work from like the exam guide. So I can't say with any certainty, but I can give you my best guess, which is the answer is yes. And I say this seeing what I've seen, like with changes in the Cloud Architect exam. They definitely have changed the Cloud Architect exam as services have changed. For example, there's more emphasis on like Kubernetes and Anthos. For data engineer, I suspect there will be changes, and we'll probably have to look. I'll have to look at the exam guide in more detail, and maybe look at like earlier versions of the exam guide. I wonder, with the advent of the machine learning engineer exam, if there will be less emphasis on machine learning in the data engineer certification, but I'm not sure. That's something that really gave a lot of data engineers a lot of trouble, because a lot of times, if you work in data engineering, you're very familiar with that and the tools that we kind of talked about. And machine learning was kind of a very specific thing. So there would be questions on things like, backpropagation and, gradient descent and things like that really aren't the kind of things we do in data engineering. It's much more the kind of thing you do if you're like a data scientist and work in ML. So there may be some changes there. There may be less of that, but I'm not sure. Here's a question. I'm studying PySpark, Dataproc templates. Will the Dataproc templates help me? Yeah, I think, the templates are really good at looking at understanding patterns, like design patterns. So I would definitely say, if you have some time and you want to take a look at the how the templates are structured, that you would definitely be useful and kind of help, you build up your own store of patterns and things like that. Let's see, can we use Bigtable for building an operational data store? Probably not. That's probably not a good fit. That's a great question, by the way. Operational data stores typically are used to consolidate data across multiple services. So as more and more people move to using microservices architecture, a common pattern that we see is that one microservice has one database. So you have sometimes in OLTP systems, a lot of small databases. And so an operational data store, or an ODS, is a way of, say, taking the data from all these smaller, very service-specific databases and consolidating it into a single logical organization. So ODSs are typically done in relational, like in Postgres, or if you have a very large one, you might want to use Spanner. But Bigtable probably wouldn't be a good fit. ODSs typically are normalized, so you want to be able to take advantage of joins and things like that. Bigtable is really good when you have a lot of data coming in really fast and you need to write it quickly. So it's really good for that. Or if you have large amounts of data and you want to, say, look up a specific piece of information, like what's the sensor reading from this IoT sensor at this point in time, or you want to scan a very limited range, like I want to know all the data from sensor 123 between 10 a.m. and 11 a.m. That's where Bigtable really shines. Yes, Stanford using machine by entering. Yep, I think. Yep, there we go. Let's see. Oh yeah, machine learning mastery. Thank you, whoever posted that. Chavesh, thanks. Yeah, Machine Learning Mastery was the name of that site that I was trying to think of. So yes, that's great. Thanks for posting that. Oh, if you want to build a data lakehouse on Google platform. Yep. Let's see. So there's this idea in like data warehousing and analytics of a data lake, and a data lake is basically a collection of data, and you store data in fairly unprocessed form. Basically the idea is you just want to get the data in and store it, and you'll go back and look at it later. That's a data lake. And now there's a concept of a data lake house, which is a more structured version. It's like, okay, you've got all this data in a data lake, you've collected this. Typically a data lake would be in cloud storage. And now you want to organize it and have maybe derive some more structured information from that. You could use things like BigQuery for that, for doing like data lake, again, organizing things. That's probably the better option rather than using, say, something like Postgres. If you had something very small, you could use it there. But then there are other tools like the metadata catalog, Dataplex, which is kind of evolving. It's fairly new. You'd probably be using tools like that. Let's see. Oh, data governance, yeah. Yeah, data governance, it's this practice of just making sure that we, like as data engineers, machine learning engineers, are using data in compliance with whatever rules and regulations we need to follow. And so people who do data governance, it's kind of like people who do security. It's there's no single tool that you use. It's just it's practices. So in terms of data governance, things like the object lifecycle management and cloud storage could be helpful. Things like IAM for access controls would be useful because you can say define roles. And for example, you may be in an industry like healthcare where only certain people are allowed to see personally identifying information about patients. And so from a data governance perspective, you would want to define the roles, like only these roles can view that data. And then you'd want to assign permissions using IAM to those roles so that only those people in that role can see that particular data. And so definitely cloud governance would use IAM and things like lifecycle management, and then also monitoring and logging, especially like audit logs, like who's changing data, who's changing, granting privileges to different people. So I would say those are probably the three main things: the cloud storage lifecycle, IAM, and logging, monitoring, particularly audit logging. Let's see, to become a Google Cloud data engineer, what other existing languages, software is required, like SQL, Python? Okay, let's see. To pass the data engineer certification exam, there are no coding questions. You won't see something like how to specify a dictionary in Python or something like that. You definitely but to be a data engineer, to really be a successful data engineer, you definitely want to know SQL. You definitely want to know Python. Those are really two foundational ones. And then in terms of the software systems, I would say it really depends on the applications. Spark is really popular. Hadoop, much less so. Hadoop is still being used in places, but it's really more designed for big data batch processing. There is a package on Hadoop called Mayhut, which was designed for machine learning. I don't know if it's really used much anymore. It was really hard to do machine learning in Hadoop. And that's one of the reasons Spark took off. There are a number of reasons, but Spark and PySpark make it easy learning. So I would say I would focus on also learning Spark. And Cloud Data Flow is something to know. If you're working in other clouds, if you're working like in AWS or Azure, probably Spark would be the first one I would suggest learning. And then I would also get familiar with some ETL tool. And it really doesn't matter which one it is in cloud. You can use Data Fusion, but if you're familiar with Fivetran or some other commercial tool, that's really helpful to know. I'd say those are the two big ones. Especially if you're kind of more toward the back end, like the storage ingestion. If you're want to focus more toward the other end where you're more interested in analysis, then tools like Looker are useful. I didn't talk about Cloud Data Studio, which is a reporting tool. That would be important if you're more interested in working with the final data, like the pre-processed data, and you want to work with it. Then those are the tools to work with. Let's see.
Dheeraj, in the meanwhile, can you share the speaker board for a couple of participants who are joining from India, and they may be late. So, Dheeraj.
Sure.
And we'll continue the question hour. Yes.
What?
Let me share my screen real quick.
Okay. Great.
And then we'll go back. Question hour.
Can you see my screen?
Yes. Yep.
So can you guys go ahead. Go ahead, please.
Just copy and paste this and paste this here, Dheeraj.
I'll do that.
Chat window. And you can use this link. This link is for taking the certificate, downloading the certificate, watching the recording, all Dan's the PDF link that he will give us for his session, everything at a single place. This is the link. You just log in, and you see there is a claim certificate link. Dheeraj, you can point. So you just put your name. I think it will automatically pick up. If you are from a Mac, then it may do some magic. But mostly it will pick up your details if you have joined from the 5th IR. And then you just put in the speaker code, which is Y0RMK2. And the certificate will automatically get attached to the same place. So instead of claim certificate, it will say download certificate. After 10-15 minutes, you can come back to the site and download it. And it will always be there. It's a digital certificate, and it has this direct LinkedIn. You can attach it to LinkedIn, share it anywhere, and it's valid for 2 years. It will be on the site. It's a digital link. It's for you. It's like a batches, right? So it's digitally signed. Now, tech quiz obviously is not there in this session. Download file. Here you will get the PDF that Dan sends me within half an hour, 1 hour. And if there are extra video, if Dan wants to share that, we can attach it here. And obviously the source code he talked about, we can directly link to it. The GitHub link that Dan was talking about, we can take it from his presentation and put it there. And this is where your recording will come up, where the picture is coming. So even the session is streaming here, and the recording will also come up here. So hopefully, I think this answers everything to you. I will pass this message to the people on the YouTube, okay, or on the site so that they can view. And yeah, so Dan, back to you. Sorry for disturbing you.
Oh, sure. Oh, no, great. Thank you. Yeah, just a couple other questions. Somebody asked, can we create visualizations like Power BI and Google Cloud? And yes, Data Studio is a tool you can use for that. There's another called Looker. I haven't used Looker, so I'm not as familiar with that, but definitely those two can be used for visualization. And I think that may be all the questions I see in the WebEx chat. I'll just quickly skimming to make sure I didn't miss anything.
Question I got from YouTube, that can we generate a visualization like Power BI and Google Cloud? Yes, right. So just
yes. Data Studio is one that you can readily use. Google also acquired a company called Looker, which has a really powerful visualization tool. I would suggest looking into Looker. I haven't used Looker myself, so I can't speak to it more directly than that. But I've seen some presentations with it, and it's really impressive. So I would definitely suggest taking a look at that. And Looker works across cloud, so you can also use it like in AWS or Azure. So that might be a good one if you're interested in visualization and sort of ad hoc reporting and tool building for end users. That would be a good one to look at. What's the difference between Cassandra and Bigtable? Well, so they're both, the similarity is they're both NoSQL databases. They're both wide column databases. They have fundamentally different architectures. Cassandra uses a ring structure. So basically, with Cassandra, the way the data is distributed is based on a hash function, and you basically write data to different nodes in the ring. And in Cassandra, when within a ring, for example, one of the ways they do high availability is, you have one node in the middle, and it might replicate its data to the two nodes on the side of it. And that way it provides high availability. If that primary node goes out, you can still read data from the other nodes. With Bigtable, the architecture is different. It isn't a ring structure. It's much more hierarchical in the sense that we have multiple nodes which manage metadata, and then the metadata the data is actually stored in the Colossus file system. So Cassandra stores the data and any metadata on the nodes in the ring, and Bigtable just stores metadata within the cluster and then takes advantage of the Colossus file system to do the storage. But from a programming it and kind of things like avoiding hotspots and coming up with row keys, there's similar kind of problems, because again, they're both based on sparse multidimensional arrays. Which is better? Oh, that's always a great question. It all depends. So much of it is dependent on what you're trying to do. If you're not in Google Cloud, Cassandra's great. If you're running in AWS, I think AWS has a managed Cassandra service. I may be wrong about that one. Yeah, I mean, there are differences there in terms of like how you manage it. Like growing the Cassandra cluster can be a little tricky because of how when you add new nodes, balancing the data can be a little bit tricky, and sometimes that can be easier with Bigtable. It may be the case. Bigtable can get expensive, especially if you're dealing with very large databases. So you may find that Cassandra might be less if you're running Cassandra yourself, but then you pay for managing it yourself. So it's an interesting question, and it's the kind of thing that I would say the best thing to do is if you actually have an actual use case, is you do prototypes on both, because that's the only way to know for sure what's right for your particular use case. Let's see. Service mapping cheat sheet between AWS and GCP. I don't, but I have seen some, and actually Google has some. That's a great question. I'll see if I can find a link to the GCP's AWS mapping, and hopefully I'll get that and get that sent over along with my copies of my slides. Okay, I think that's all the question. Oh, somebody talked about Terraform. Yeah, I haven't mentioned Terraform. Terraform is used for defining your infrastructure. I've heard the phrase infrastructure as code. Terraform is an open source tool. It's supported by a company called HashiCorp. And basically, you can specify the kind of infrastructure you want to create. So if you want to create a bunch of compute engine, virtual machines, or a Kubernetes cluster, or a Bigtable database, you can specify, or AWS, if you want to create the equivalent resources in AWS, you can use Terraform. Terraform has definitely seems to be becoming a standard infrastructure as code tool in Google Cloud. There's also, they have some Google specific like Cloud Deployment Manager. I think the tendency is probably going to be to adopt Terraform. So yeah, that would certainly be a good open source tool to know, and it would be useful across clouds. Can we real-time stream the data from BigQuery? Oh, from BigQuery to BigQuery. You can ingest data in streaming data into BigQuery. Now, BigQuery doesn't have the low latency writes of Bigtable. So what you might want to do is stream data into Cloud PubSub, and then stream from Cloud PubSub into BigQuery. That way, if you get just a burst of activity and BigQuery is not able to keep up, it'll be cached in PubSub until you have time. Great, somebody posted the AWS GCP multi-cloud service cheat sheet. Thank you. Oh, interesting. You want to transform data from data store into CSV, but I guess Spark doesn't have a connector for data store. Oh, that's interesting. I haven't worked on that. I would say there's definitely you could use the data or the Firestore API and use Python. You should be able to use the API directly from, say, PySpark. That's an interesting question. Yeah, I would say I would try the Firestore API. That would probably be the first thing I would try. BigQuery does not support downstream data using PubSub. I'm not sure. Downstream meaning from BigQuery to PubSub? Not quite sure about that. Okay. Yep. Yeah, I'm sorry I didn't talk about PubSub more. It's really, that is a fantastic tool, and it's such a great service. It does, such a key thing, which is basically, help you do low latency ingestion on streaming data, and you don't have to deal with, worrying about scalability and managing clusters and things like that. Here's a question: which is the best coding language, Java, Python, for data engineering and GCP? My preference is Python. I mean, I work with Java, but for me, I mean, my preference is Python. It's very efficient. It's very fast to write code in Python. I find it very efficient. If you need a lot of low-level, intense computation, a lot of the libraries like NumPy, SciPy, they're all written in Fortran, and they're just wrapped in Python. So you still get efficiency, like you can do high-performance kind of computing stuff using Python because of the fact the libraries are written in other languages. So that's my preference. But if you already know Java, you can certainly use Java in PySpark, Dataflow. But I would say if you're just learning one and you're new to a language, my guess is that you probably pick up Python faster than Java. You can do more with Java. Java's really has kind of a complex ecosystem around it too as well. So yeah, just my thoughts on that one. Let's see, DataStax. There's some thoughts about DataStax had the option of running Cassandra on GCP as part of AstroDB. Oh, interesting. I didn't know about that. That's cool. Easy way to learn Python language. Let's see. There's a lot of tools out there. I would say I don't know if there's any resources on multi-cloud for you, but otherwise, there are. Oh gosh, probably the best reference to get started is Thinking in Python, which is a book. It's online. It's available. You can download the PDF for free. I would definitely suggest Thinking in Python, and that helps you think. Really, it's not just geared toward data engineering, but it's really geared toward Python in general. So that's what I would recommend, and I would definitely just start coding in Python. As soon as you open that book, just start doing exercises. I'm very much an advocate for hands-on learning. Just try as you learn and build stuff. Yeah, so I don't have better answer on the easy way to learn Python. I've been using Python for a long time, so it's been a while since I've kind of gone back and looked around at what courses are available. All right. Well, if there are no more questions, thanks everyone. And yeah, I thought these are great questions, by the way. Really digging in, and thanks for the feedback on things like not mentioning Cloud PubSub. I realized I also missed Data Studio, which questions came up about that. So maybe in another session we can focus on those or have a little more targeted discussion.
Yes, yeah, this was really much needed session. We are waiting for it for almost a year now. And thank you, Dan, for giving us the time from a busy schedule. And I think people are loving it. We can see. And for the Python, we have sent one link, which is we run a parallel program for kids to turn them into early entrepreneur, changing to a different way. So they learn blockchain, they learn a lot of things. And even my daughter and Dheeraj's daughter and multiple kids are there from all across the globe. They make courses and do a lot of activity on different things. And they have grown up very smart with the time. So they have created for Python specifically, and they are going to add up more, and they are going to also create it on 5th IR with the time. Whenever they get some time, they build on. So you will love it because kids can better because they have their own language to understand things, right? So understand like a kid, right? So learn from them. Yes. And so I will share the slides as soon as I get from Dan. I will quickly get the slide from Dan, and then we'll attach it on the 5th IR platform. And those who are waiting for their certificate, they will also get the email, maybe a little delayed because we quota it for multiple regions. But obviously, once you go back to the site within 10-15 minutes, half an hour, definitely will get the download link at the same place that we saw you. And also would request you to give us feedback, share it on LinkedIn, share about the session. And whenever we'll get more time from Dan, we promise we will bring Dan back again.
Oh, thank you. I'd enjoy it.
Yes. Yeah. So thank you, Dan. And thank you for your time.
Thank you, everyone. Take care.
Yeah.
Yeah, thanks all. Thank you so much, Dan.
Thank you. My pleasure.
Bye.